Welcome to this video tutorial. Let's get started. So first of all, I would like to explain the functionality of files. Here is the line data. This is the second column is from bus, and this is to bus. I mean from one bus to three bus. And first column is just a serial number, and then we have resistance and then reactance of each uh, bus. After that, let me explain the load data file. In load data file, this is the kilowatt real power, real load, and this is the kilowatts reactive load. So after that, let me explain the SW data file. So let me show you the reference. Here is the reference paper for solar and wind data. So the reference second column is the solar irradiance data, and which depends upon the time. So here you can see the title of this paper. So second column depends upon the time between 8 p.m. To 5 a.m. The solar irradiance and the power generating from the solar is will be the zero. Okay, so here is the calculation, and here is the problem formulation for solar. So you can also take a look at the features of explanation of the uh, components of this formula. So this formulation can be used as a reference, and also the calculation which is made through this program is let me show you. So the solar power generated is 1.191 per unit. So let's jump into the program. So in the program, exactly perfectly is chosen, and then exactly same parameters are selected. So let me run the program. When I run the program, then solar power is 1.19, which is exactly same that is discussed in the paper. So I have just multiplied this factor with the 3 times. So we have to make it around 4.76 because our according to our network, we need a power that is around 5 megawatts of the solar. So that's why multiply it with the 4 times. Here you can see that. Okay, after that here is the without DG calculation. In the without DG calculation, first column is the voltage profile, and second is the power losses, real power losses. Here you can see that there is a formulation or calculation how without DG is calculated. Without DG dot m file is calculated through WODG calculation. So then I just put the numbers in the without dg.m file, so later I use this as a comparison. And now jump into the PSO main file. So here first of all you can choose when I run the program, you can choose number of DGs for so DGs is not any name here. DG means it can be a PV or battery energy storage system. You can choose it 4 or 2. If you want to put 4, then you can choose 4 PVs with 0 battery storage system, or if you want to choose 4, then you can choose 2 battery energy storage system, and then you can also choose 2. So let me break the program. Also if you want to run the program, you can choose 2, and then you can choose 1 battery energy storage system, and then you can choose 1 PV. And the third combination you can choose 4 DGs, put 0 battery storage, and you can choose 4 PVs. So these are the combinations you can utilize. So let's jump here. Here you can see that this is the minimum location for So this program is for the battery storage system, and the below program is for the PVs. So everything inside this one is for battery storage system. So here is the minimum location, possible location, and this will be the maximum. So PSO help us to find the best location. So this is the maximum, this is the real power, and this is the reactive power injection. So I just choose reactive power injection of maximum 4500 kilowatts, 4.5 megawatt, and this is the PV. And here still minimum location is 2, maximum location is 14, and here is the power that I calculate from the SW data file, and that is up around 4.76 4.765 megawatts. So total will be around 9.5 megawatts from. So total combination will be from 0 to 9.25 or something. So so let me run the program. Let me click here and let me run the program. Let me break previous program. Let me run the program again. Let me put 4 2 2. Okay, so here let me show you. Okay, so here you can see that initially I have put 4 zeros. Okay, so these 4 will be the first 2 will be the real powers, and then will be the reactive powers for battery storage system, and then these will be the zeros for the PVs, and real power zeros, and then this will be the uh, reactive power for PV, that is minimum value, and then this will be the locations, minimum locations. Okay, and let me then run the comics. Okay, so here you can see that this is the real power, as we have to choose reactive power injection. So initially all are the zeros, and then we have 4500 battery storage system maximum power, and then 4765, that is the PP maximum power, and then this is the maximum power for maximum possible location for our battery energy storage system, or PVs. And then let me move into this time and click OK. So when I click on this step, here you can see that what is inside here. So PSO now will choose any value between. So before we have 4 zeros, and then we have PV reactive power, and then we have so this is the choice between 0 to 4500. 0 to 4500. So PSO choose this value, and then 3.8, and this one is chosen between 0 and 4765. And then we have 4 locations. These are in point because we have to multiply all the numbers by 1000. Okay, and next at this point we will be jump into the load flow file. Let me put a number here, and then let me click run. Okay, now we are here, and let me show you what is inside the DG. Let me again, here is similar thing. The previous an assumption which is made by the PSO is now into the load flow. So exactly same variables that are above and are now into this program. So here we have to done this function I have done now. Previously it was not this if else condition. So this if else condition is restricting the same locations, same location for both solar and battery energy storage system. So here is the real power injection, that is 0, and then we have the reactive power injection, that is. So also I have made only reactive power injection, and that will be on the QG buses, not on PG buses. So Let me run the program here and click on the continue. Here you can see that. So the injection is on these buses, because we have on total we have here four combinations, because we have choose 4 DGs, two battery storage system and two PVs. But our restriction is that we have to put them at the same number. So let me click on the PG. So no injection in the real power. So this was actually the real challenge. And after that we have to run the program. Let me demonstrate this a bit more. Okay, and now I want to choose how much n I have. 1, and let me click on continue. Click on continue. Sorry, now it is running for second time, and now we have n equals to 2. And then let's see, we have real power, and still let's check. PS is 0, QS is value, and then we have again. So a similar process will repeat, and we have and now I want to continue the program. Let me break down the red buttons and click on the continue. Okay, so through this file we are getting to find the losses, and then we will make comparison. And up to this point, up to finding the global best position, global best cost, we utilize load flow. And when we have done with our global best, I mean best uh, injection power and best location, then based on that results, we will get into this file load flow tool. So when we done with the best location, best size, then we will make these outputs as inputs to this load flow to file. So let's finish this program before, and then we will move further. So in global best position, we will be our input, and input will be the location, and this will be the input, just like this. But this is a fixed number, and from this you can get an idea that this is our input. And what will be our output? The losses which we get will be the our. So let me just check what is inside this function. So these are the uh, power for battery storage system and PVs which got from the load flow file. So these are the four numbers, and sorry, uh, 3 and 4. And these two locations, and these ones are the best location. So when you will multiply this with the 1000, then it will be 5.1, which will be round off to around 5, and this will be around 7.8 to 858, and this will be 10, and then this will be the actually the insertion is based on these locations, and these are last two ones are just extra. So in this program I have made arrangements that the placement is based on these numbers. So now we are getting into the load flow 2 file, and here we have done it. Okay, so so let me click on the continue button. Okay, so here we have done, and here we have power loss without DG, that is 417, and 480, that is I put here fixed numbers. How I get these fixed number? I get from the without DG calculation file, from this file. Okay, and then I here you can see that we have megawatts power. Sorry, this is kilowatt or kVAR, and that is 3.3 megawatt, or 33 kilowatts, and 325. Both PV and battery system are placed on the same location. And here we have reactive power as well. So locations are same, and real power is same. Only we have to consider the reactive power injection, so that's why real power get zero numbers here. So this is the voltage profile, and this will be the power losses, and this will be the convergence curve. So that's it. So I think if anything is left, you can ask, feel free to ask any question, and hopefully this will helps you a lot. And thanks for watching.